Hey guys, today we're doing notes 50. So this is trigonometric ratios, and it's our friend SOHCAHTOA. So that's what we'll be thinking about today. A couple of vocabulary pieces just so we're all on the same page. A trigonometric ratio, they're special measurements of a right triangle. So then remember that's a triangle that has one 90-degree angle in it, which means you can only use them for right triangles. So whenever we think of SOHCAHTOA, we want to make sure that we are only using it with a right triangle. We're not trying to use it with a triangle that looks like this. There are three basic ones, which you probably already know, and then there are three inverse ratios, which might be new. So we're going to talk about those today. So here we have our original ones and then our inverses. So as you probably remember, we have SO, Ka, and Toa. Right? So sine, we abbreviate to SIN of the angle. Right? Remember that we have to go to the angle and then we can label our sides. So directly across from it, this would be our opposite. The long side is going to be our hypotenuse. And then the leftover side, which is usually, it's always the side next to it, would be the adjacent. And so our sine is our opposite over our hypotenuse. So that would be opposite over hypotenuse, which in this case is z over x. And so we would write these, whatever these numbers are, say this was 3 and 5, we'd write 3 and 5 there. So pretty simple. The inverse of sine is something called cosecant. So we abbreviate that CSC, and we would still have the theta there. And then the inverse is actually just flipping it over. So this would be the hypotenuse over the opposite. So in this case, in this problem here, it would be x over z. So cosecant, just if you see that, you don't have to freak out. Just CSC is the opposite of sine. And so we'll see all of the inverses have opposites based on their piece. So cosine, we abbreviate to COS of theta, is the adjacent over the hypotenuse. So in this case, again, we go to the angle. We go across, that's our opposite. We find the longest side, or the one that's across from the 90-degree angle. That's going to be your hypotenuse. And then the leftover one is your adjacent. So in this case, we have our adjacent, which in this case is k, over our hypotenuse, which is m, just like that. The inverse of cosine is called secant. We abbreviate it SEC. It's going to be of our theta as well. And it is the opposite, or the reciprocal, of cosine. So it would be hypotenuse over adjacent. And so that in this case would be m over k. So that is our cosine, and our secant is the opposite of our cosine. And then finally we have tangent, TAN, which is TOA, which means opposite over adjacent. I'm going to go to my angle, go directly across, that's my opposite. My hypotenuse is the side across from the 90-degree angles, and the leftover is the adjacent. So in this case, I have y over z. As you can imagine, cotangent is COT of theta. It is the inverse of tangent, so that means that it is adjacent over opposite. So we have our adjacent, which is z, over our hypotenuse. Over our opposite, which is y. And so we'll have all of these will be the opposites of the pieces they go to. So I always like to remember SOHCAHTOA, which is the normal one, and then then you only have to remember which ones are the opposite. So cosecant is opposite of sine, secant is opposite of cosine, and cotangent is opposite of tangent. And that makes it a little bit easier to remember. So we're going to go ahead and take a look at a couple. look at 1, 2, and 3. So I marked out some steps here, marking the angle. So we're going to start by marking the angle that we're looking at. So in sine 1, it says sine C. So I'm going to go to C, and I'm going to mark that angle. Right, that's the angle that I want. I can even put a theta there if I want. Then it says label opposite, hypotenuse, and adjacent from that angle. So it's super important that it's from there. So across here would be my opposite. The longest side would be my hypotenuse, and then the adjacent is left over. In this case, they want sine, which is SOHCAHTOA, so sine of theta equals the opposite, 21 over 29. Check to make sure that that is simplified. There's nothing I can divide that by, so that would be my answer. So again, if I'm thinking about this, I'm going to mark the angle that I'm looking at. So this says cosine C as well, so I'm going to go to C and mark my angle. I'm going to label opposite from here. This would be my opposite, longest side, hypotenuse. Leftover is adjacent. I'm going to use the definition, so I want cosine. Cosine is adjacent over hypotenuse. So in this case, it would be 8 over 17. I checked to make sure it can't be simplified. 17 is a prime number, so I know that it cannot. And then finally, I have tangent, so I'm going to mark the angle, tangent A. So I'm going to go to the A, that's what I want. That tells me that this over here is my opposite, my hypotenuse, and my adjacent. Tangent is opposite over adjacent. So I know that this is opposite 12 over adjacent 35. There's nothing that can be simplified, so I'm done with that problem. Alright, from here you are going to work on numbers 4 through 8. So those of you who aren't listening, I'll just make this note for you. Numbers 4 through 8, and get it checked off. Awesome. Thanks, guys. Ask some questions. Bye.